In this video, we're going to analyze some graphs of different either relations or functions. Not everything in this packet is a function. So we're just going to look at selected graphs and selected information for each one. So let's go ahead and look at the first one. So there's some questions on here that we ask for the majority of graphs that we look at. So with domain, that happens to be our x values are input. So I need to remember that those are x values. So when I'm looking at this graph, when I go to find my x values for anything, so if I want to find my x value of this point right here, I have to look to my x-axis to figure out what that is. If I want it for this value right here, I look at my x-axis to see where that is. And that's true for any value of x on that function. So that means I take my ruler and it always touches the x-axis because that's where I look to find my values of x. So it does not touch the graph until I come right here. Right here is where x is what? X is -1. So I know that, I'm going to write it down here in interval notation just because it's easier. I start at -1. It includes -1 because that's a closed circle. So for interval notation, this means includes. And I move my ruler all the way until it no longer touches the function. That would be the last place where it touches the function. And that's where x is 1, 2, 3, 4, 5. That's where x is 5. And that includes, excuse me, wrong symbol. That includes 5. So again, we're going to use like that brace. Okay? So for set builder notation, this curly brace means set. So I'm going to do the set of what? Well, my sets of x values such that, well, where's my x? My x is between here and here, right? So that means my lowest value is x, and it includes it, and my highest value is 5. So this notation means the same. So let's go ahead and let's look at range. So remember, range is my y values. So where do I go to look for my y values? I look for my y values on my y-axis, which means I'm going to hold the ruler so that it's always touching the y, so I can look to see what my value of y is. So I start from the bottom and I move up and I don't touch the graph until I come to this point here, and that's where y is -1. So it includes it. And then it keeps touching this graph until I get to here, and then it doesn't touch anymore. And that's where y is 2. Because it's a closed circle, it includes it. So set builder notation would be the set of y such that y is between -1 and 2. Okay, so these both mean the same thing. It's just a different way of saying it. So let's look at some other vocabulary over here. So we're going to look at zeros. So zeros means, let's just write this over here. So zeros is the same as x-intercept and another way of writing x-intercept is I'm looking for some value of x where y is 0. So zeros is shortcut nickname for where y equals 0. We can also say y like this. F at x is the same as y. So where y is 0. I'm looking for some value of x, excuse me, when y is 0. Some other vocabulary that you will encounter will be roots and solution of the function. I'm going to write of the function. Typically we just say solution. Okay, so if I'm looking for x-intercepts, that means I'm looking for where it crosses my x-axis. And it looks like there's an x-intercept right there. Because I don't have an equation, I'm going to have to estimate what that is. So it looks like my value of x, and you can write it as a decimal, is 0.5, where y is 0. So this here is a point. So let's talk about increasing intervals and decreasing intervals. So by definition, increasing interval, again, we're looking at values of x. So here, this is values of x that increase the value of my function. Okay, that's by definition. Decreasing interval is values of x that decrease the value of my function. Sorry, this is f of x, which is the same thing as y. Okay? So let's look back here. So I have to ask myself, if I'm going left to right, do I have an increase in y? I do. This part here increases. So that means when I'm looking at my value of x that increases the function, my value of x, remember, starts there, and it increases everywhere to here. So that's my increase in my function. So that means that my function is increasing where x is what? Where x is -1, all the way to where x is 5. And this here is an interval, not a point. Do I have any place where it's decreasing? No. This is a positive slope. It's increasing everywhere. So this one here is none. Constant interval would mean that there's no increase and no decrease. And I'll let you know that this example down here is constant. It doesn't increase, it doesn't decrease. So in this case, this is none. Now, end behavior, we've not talked about end behavior. So with end behavior, I'm looking at the ends. So when I'm looking at the end here, this is saying as x goes to -infinity. So x goes to -infinity along this route. So when we see this, we think of the left side. And here, this is where x goes to infinity. So if I'm looking at my x-axis, I'm going this way. So this here would be the right side of the graph. So where is my function going? Well, actually my function stops right here where y is -1. Okay, so this here is actually, this here on this side, it stops at where y equals -1. So this here I'm just going to put -1, though technically it's not going that way. And here this stops at y equals, well, what's the value of y? y2. Okay. Okay, so that's that example. And we'll look at a couple more in another video.